Hey, polar bears and polar cubs. Let's talk double roadmap. Now, this is stoich light, as I like to call it. It's just about stoichiometry, but it's not the full thing. What this is within a compound, we can use the molar ratio to go from one part of it to the whole or from one part to another. So, for example, we could have sodium chloride and we could have that in mass. I could take it to moles of sodium chloride, but then I could actually transfer it over into just the chloride ion or just the chlorine atom. So we can do that. The same rules apply. You can go from moles or mass to moles, particles to moles. The only thing that we're really adding is this central line to go from mole to mole. So you can go right here. And that is the mole ratio. So you have to use the mole ratio in order to go between the two different substances. So we're going to use some subscripts. And the best way to do this is to see some examples and try one yourself. So example number one, I will run through. It's calculate the mass of sodium oxalate. Sodium has a +1 charge. Oxalate is C2O4 with a -2 charge, giving us Na2C2O4. And we're going to get that many sodium ions. So we're going to start in sodium ions. That is 800 or 8.46 times 10 to the 23rd. Na plus ions or ions Na plus, either way is fine, over 1. The next step is to get out of ions and get to moles. So as long as you can get to moles, you will do great. First step, get to moles. So we're going to have mole Na plus over ions Na plus. Now, at this point, we are in moles of sodium ions, but we want to get out of moles of sodium ions and into sodium oxalate moles so we can eventually get to the mass. So this is where we use the mole ratio. So we're going to use the mole ratio. I'm going to put it in brackets so you can tell that it is different. So up top is going to be the type of moles you want to get to. That would be sodium oxalate, Na2C2O4. And down below would be the moles that you were in. Those would be just moles of Na plus. Notice how we have mole up top and mole on the bottom. Well, now we've already we're in moles of sodium oxalate, so we can go directly 2 grams of sodium oxalate. So we're going to put the mass up top. This is going to be Na, and I'm going to go down with it, 2C2O4 over mole of Na2C2O4. So let's plug in some numbers now. The last part that I like to do is the mole ratio. So every mole that's outside of the ratio is a 1. Ions, that's going to get Avogadro's number. And grams, you're going to have to calculate that mass. So we're going to take 22.99 times 2 plus 24.02 for the 2 carbons, plus 4 oxygens is 64, giving us a grand total of 134.00. gram molar mass of sodium oxalate. Now comes the mole ratio. In our questions, we are going to have the entire compound. This will always get the 1 for the mole ratio. For the moles of the other, we're going to look at the subscript of it within the compound. So the subscript on Na is 2, so it gets A2. All right, we're going to do the same thing that we've done in the past. You're going to take the tops, multiply them together, multiply the bottoms together, and then do one division problem. So on the bottom, you're going to get 1.2044 times 10 to the 24th. On the top, you're going to get 1.13336 times 10 to the 26th. Now we're going to take some division. So you'll take 1.1336 divided by 1.2044. This is going to give you a 0.9412 times 10 to the second. So this is going to get brought back 2 spots. Well, 1, knocking this down to a 1. And then we're going to put it in regular formation. So if we bring this back 2 spots, it should end up right here, giving us a final answer of 94.1 grams Na2C2O4. All right, I'd like you to try the next problem, and then you can let me know, or I'm going to count down and show you the work and final answer. All right. 5, 4, 3, 2, and 1. Number 2 says the mass of chlorine atoms that could be obtained by this many grams of dichlorine monoxide. So that is a Cl2O, di standing for 2, mono being 1. So we'll start out with 36.46 grams of Cl2O over 1. We're going to get to moles real quick using mole Cl2O over grams of Cl2O. Now we're going to be into that molar ratio. That's new. So we're going to have mole of just Cl. And since it's atoms, there is no charge. Put over mole Cl2O. And then finally, it asks for the mass. So we're going to go right back to mass, but it's just going to be of chlorine. So grams of Cl over mole Cl. So moles on the outside are going to get 1s. Mole inside for the entire compound is a 1. For itself, like chlorine by itself, is going to get a 2 because of its subscript. Gram molar mass, you're going to have 70.9 plus 16, giving you 86.90. And we're going to 35.45. If you're wondering how I got 70.9, I took 35.45 and multiplied it by 2. So take your tops. Because there's no exponent on the bottom, you can take 36.46 times 2 times 35.45, and then divide that answer with a parenthesis of 86.90. giving you a grand total of 4 sig figs. So you got 29.75 grams. Grams of chlorine. All right, there's our notes over double replacement, or not double replacement, double roadmap. Go ahead and try your worksheet and let me know if you have